right, so this is another of our interviews covering those who have won the Technical Achievement Awards at Microsoft. Who are you?
I'm Nick Baker, manage the console architecture group. We're a Mountain View-based outpost.
Excellent.
California.
Excellent. So now you've won the Technical Achievement Award for the work that you did on Xbox 360.
Correct.
Congratulations.
Thank you.
So let's talk a little bit about that. What is the Xbox 360 from a system point of view?
It's a white box. Has some green flashing lights on the front.
Okay.
No, it's a game console. It's designed from the inside out, basically, to run games.
Mm-hmm. Understood. So, is it running like a modified version of NT?
It's basically. I mean, we took the whole. We only have one piece of hardware, so it's like, driver, HAL, OS. It becomes a little bit more monolithic, and we can optimize things basically for the platform and remove layers as they're not needed. But the strength really is to have Win32 there as a API that the developers are familiar with, and then also DirectX. And that's what really gives the box's power, and also Visual Studio tools and everything, a familiar PC development environment.
Absolutely. So it's basically a PC that's targeted at games.
Correct.
100% at games.
Yeah. Although we are PowerPC, which is a little bit different.
Okay. Interesting. So can you explain that, like a little bit different?
Yeah. So the design philosophy that we pursue is. We try to take technology, the PC industry. We try to take the best of the PC industry. We go out and talk to the IHVs, understand where they're going to be in our sort of launch window, and from that we kind of construct a map as to what makes sense to build in this time frame, what's going to be relevant for technology, but we also need to do that in a way that we can deliver in a consumer electronics experience, and also within the game console, which has certain requirements like a large number of units out there which behave exactly the same. You don't want to spend a lot of time in testing different hardware configurations.
Sure.
So we take the PC pieces, mix them around a bit, and come out with something which makes sense for us, and then we can control and cost reduce over the lifetime. We were able to go with PowerPC though, rather than x86, and, which was one of the first interesting challenges we faced, was to convince the rest of Microsoft that this was a good idea.
So let's talk about that. Why was that a good idea?
Really, what we wanted was to, if you look back now, it seems obvious to everybody with like the Core 2 duos and stuff like, and quad core CPUs coming out soon. But back when we started in 2002, it wasn't as obvious that the trend was going to be towards multi-core CPUs. But when we started looking at our roadmaps and really seeing where the silicon technology was heading, we started seeing that frequency power wall creeping up on us, and so we went back and scratched our heads a little bit and said, well, maybe there's a different way of tackling the problem. I mean, game pipelines, you do have different levels of code, and some of them are amenable to running on different types of processors. So shaders, definitely want a GPU for it, but things like physics, maybe we could go with something a little bit more novel to run more floating point, general purpose code, not shader kind of stuff, but more general purpose floating point. And so first block diagrams that we drew really had, well, let's put one x86 CPU here, because we think we're going to need it to run like the high-level game code and stuff like that, large out-of-order machine. But let's focus on like this floating point general purpose array and see if we can, maybe there's we were talking about like 8 to 16 at the time of how many of these little cores we could think we could do. And when we actually went down the design, it was like, well, gee, no, it actually makes more sense to go with these, because we were seeing integer numbers that were actually reasonable for these lighter weight cores. So at some point we had taken the x86 away from there, and then we had, well, let's go with at the time we were estimating between 4 and 8 of these cores. And so then we started going around and seeing, well, who can we actually work with to deliver these? And different IHVs had different opinions about where the market was heading. So we started working with the ones that were wanted to go where we wanted to go. So x86 was not in that camp, and so PowerPC, IBM has these sort of cores that look interesting, and here's why we should use this as opposed to just relying on one huge out of order machine that's it's going to take a whole bunch of power. So
excellent. So that's really visionary.
It is.
Yeah. Nice job, because now the whole everything is now about multi-core.
Absolutely.
And in fact, in 10 years, they're talking about, Intel is about 80 core.
Mm-hmm.
So you've built a system that, let's talk about that. How many cores could it support? I guess what I'm trying to say is you've built an architecture that's flexible enough such that when we do release, say, an Xbox that handles processors that have 80 cores in them,
mm-hmm.
it should be able to scale.
Right? Yeah, I don't think it's as easy as taking the 360 design and just taking that and scaling it up to 80 cores. I think the higher in the many core world, mm-hmm. it's data movement's going to start becoming an issue, and how do you actually take advantage of the parallelism out of something that has 80 cores? I don't know a productive programming language today that you could sit down and write in. So at least for the 360, we're only giving a 6-thread problem to developers. They basically have to code for 6 threads, and you can kind of squint and say, well, I do this and this, break this stuff out, and you maybe run file I/O on this thread and audio on this thread. I can get that relatively easily without just throwing everything I know about programming out the window and having to learn something new. And so maybe you can scale that a little bit. Maybe the cell, people will actually figure out how to take advantage properly of all the 10 threads there. Mm-hmm. But as you go out way beyond that and really increase the number of hardware threads, it needs to be something different.
Absolutely.
And that's going to need plumbing all the way up from the hardware up into the programming languages.
Absolutely. And people will just have to do more functional kind of programming. That's the whole. That's where C#'s kind of going with Link. To write 100% functional is definitely not productive for the average developer. Mm-hmm. Certainly for game developers. I couldn't imagine writing a game in Haskell.
Mm-hmm.
That would be kind of challenging.
Right. And so the trick is how to extract the parallelism out of languages that are
already
very sequential today.
Absolutely. So back, you mentioned the term design. Your design constraints for this console that has to run these games, very high performance rate, right, to compete with your competitors, and you have this high level graphics and a lot of really interesting things going on. As the design team, what were some of the trade-offs and balances and kind of considerations you had to make to create this little machine that can really perform well and boot really quickly and all the important things that you...
Yeah. So, there's a lot of things. So the high level, the high level goal was to meet the schedule. That was 2005. So, that drove a lot of decisions for us.
Mm-hmm.
The next sort of guiding principle is the cost, and so we want to have a box that we can sell to millions of customers, and we believe that has to be in the few $100 range, and so we had to make that work lifetime for the console. And so those are really the top things. And after that, it's like you kind of see what you've got left, and that's kind of why we started off with, say, we can go out with like 8 cores maybe, but quickly when you take the top two constraints, you whittle it down and say, well, okay, so it's now 4 or 3, and now it's 3, and that's where we ended up. So those are those are really the high level constraints that drove everything else.
Absolutely. I mean, and it's interesting, like the battle, if you will, between the architectural plan and the business plan. I mean, it's not. I don't think "battle's" the best word, but it's an interesting.
Yeah, it's an optimization global optimization that just keeps going on and on and on throughout the lifetime of the product until you launch. I mean, we even had switches in that we could throw last minute if we chose that. We wanted to go different ways, mostly to take power out of the box. No, there isn't any hidden power in the box today. Sorry, So we had ways that we could be flexible throughout, but it is an optimization that keeps on going. And so you start off, really, you want to say, well, how much product can we afford over the full lifetime? And that so you model how many units you think you're going to sell, and what price point you think you're going to have in each year, and that basically drives the cost constraint for the box. And then you work backwards from that and say, well, this much we want to put in as a WYSI controller. This one, we want to have hard drive and ship with some number of units. We have the DVD drive that's going to take out some amount of cost, and so you kind of see what's left, and we need memory there, and so
sure,
it's and then it's you have to then occasionally sanity check and do a bottoms up and say, well, do we still have something that we think is competitive? We started seeing early announcements of what the PS3 was going to be, and so we can sanity check ourselves and saying just making sure that when we come out with something, it's got to be relevant. Like I said before, for the time frame from if you just compare it to what's going to be available for a PC, you don't want it to be already last generation compared to PC games when it comes out, and you don't want to be too. And we were suddenly leaning towards where the PS3 was going to be in terms of performance. So
sure. Well, I mean, it's business, right? You want to release something that's competitive,
yep,
and that consumers are going to enjoy. And I mean, the Xbox is quite popular.
Mm-hmm.
So apparently, you did something very. Thanks. You did great stuff.
Thank you.
So, but the thing about when you tie your operating system to specific hardware, it's clearly not a general purpose operating system that you have on this. It's specific for certain types of hardware. So as hardware begins to evolve, you'll have to release new versions of your operating system, right? Or
well,
do you have to
our hardware doesn't evolve. We come out with what we launch. I mean, basically what we have to do, and is actually very tricky, is the very first console that comes off the production line runs the very last title ever to be made, and vice versa. So the very first title runs on the very last console. And we have to guarantee that compatibility. So at the end, you have tens of millions of units installed base, and if I come out with a title, I'm going to be able to run on anything. And that's basically the console. That's basically the console model. So when we come out day one, what we ship day one is basically what we have to build throughout the lifetime. And so any bugs or features as they are now, basically, that ship in the box, they have to stay there. Developers might stumble upon them and figure out how, well, if I set this bit in this register, well, gee, this funky color comes up, and hey, look, that's cool. So, well, it's not supposed to do that. Well, we're doing it now. So, and then you have to support it, right?
Sure.
And performance is the same thing. It's like anything that could impact performance. We have a performance team that basically goes in and says, this. Is this significant or is it not significant? I mean, is it something that impacts on a micro scale? So if when you blow back up into the macro scale, look at millions of clock cycles, everything smooths out again. And so, okay, that changes maybe okay. And the reason we do changes is that under the hood, we launched in 90 nanometer silicon technology. We're just going to ride that down. Basically, what we like to say is that we use plow Moore's law into cost rather than features. So as we do shrink the design, things change subtly, and we need to make sure that we try to make everything as clock for clock the same. But if something has to change, like there's a memory thing or something like that for yield or something, it's like we have to, the overall performance, everything stays the same, and so we can just write the cost down. So those are the changes we're making to the hardware. The software, they come out with new releases, but that's nothing to do with really hardware capabilities.
Cool. So, what got you into this whole Xbox thing? I mean, tell us a little bit about your trajectory into, coming to Microsoft and working on the Xbox. Why the Xbox?
I worked at 3DO. I was one of the hardware designers there, and started there in '93, and I'd done graphics at college before, and I knew it was something that I'd be interested in doing. Worked at Apple for a bit. That was on video technology, so I got a chance to go to 3DO in '93, and basically stuck with that. 3DO, a little history here, but 3DO fell apart not exactly fell apart, but they sold off the hardware business in like '97. That was a little startup called Cagent Technologies. We were a subsidiary of Samsung for a little while, and we got that lasted about 9 months, and Web TV then pulled us in to work on the next generation Ultimate TV box, which never made it to the light of day as we got out of the Ultimate TV business. But as we were working on the next gen Ultimate TV stuff, it was like, well, what makes sense for gaming on set-top boxes, and there's a sort of casual gaming space to do on a set-top box. So we were the graphics team from 3DO, basically by occasion ended up working for Web TV to try to figure that out. And then when we got involved early on with the Xbox One, more in sort of consulting capacity, because we were down in Mountain View, so there's a bit of a distance challenge there to take care of. But so when Ultimate TV then folded, we got sucked into Xbox and started working on the 360 designs pretty much January 2002.
Excellent. And you led the effort, right? I mean, that was
I led the architecture.
Your architecture team.
Yeah.
The hardware architecture team.
Yeah.
Which worked closely with the software architecture team, I'd imagine.
Yeah. Well, so we have the main. The early stages are probably easiest to say what we do at different phases of the of the program. But at the start, we're going out there and talking to, like I said, we're going out and talking to IHVs, understanding the roadmap. So that's my team. I have a handful of people, and we tried to go. We spoke to IBM, ATI, NVIDIA, Intel, AMD, a whole bunch of other companies that had looked as like they had interesting technology as well, and just understand what we could use. And then we come up with some plans based around that. Loop in the software guys saying, hey, this is what we're thinking. Work with motherboard guys saying, you think we could build some of these things? What do you think it costs on the motherboard? How do you cool this thing? And how much power do you think you can deliver? And so it starts snowballing, and then we sit down and start taking all of the feedback we've gotten and start putting some more formal, we call them request for proposals, RFPs. And that's where we're saying, well, this is kind of what we want to build. Can you build this for us? And if so, how big, how much, you think it's going to cost us, and stuff like that. And that's how we go through the vendor selection to say who our partners really want to be for the program. And then when we have selected the partners, our role changes into more of a technical program management. So we're working with, I did a lot of work with ATI, and Jeff Andrews, who's another senior member of the team, worked with IBM, and we're looking at the specs, understanding, going to their design reviews, treated as part of their team basically, and really making sure that we can optimize things for what we need, because we do have a custom product, and so it's not that we just have to run any random version of Windows on here. We have a very specific thing which we can tailor as well.
Sure.
Right? We don't need VGA, and so by being more involved with the team, we can say, no, we just don't need that. We'll never use it. And also, if some bug comes up, we're then there to go to the software team and say, can you work around this? And so they don't have to go back and fix the bug, because there's a reasonable workaround. And so, and then we have kind of help out when we get to bring up, because we understand a lot about the hardware itself. We help out and bring up and debug and and stuff like that. And I even went to the factories and had a look what was going on there, and helped out a little bit. So it changes it changes quite a bit throughout the life cycle.
So how close is the Xbox 360 that I can go out and buy today to some of your original ideas? From a hardware perspective, like how it ends up, the pack, what I get, the hardware.
Yeah, I think the very first block diagram that was drawn had a not very is the answer, but it's almost. Like I said, there were sort of three levels of workload in the game, and so there's the high level game simulation, AI, physics kind of stuff, and there's sort of AI and game scene traversal and stuff. Then there's the middle level, which is more of the numeric computation, so you have physics in there, and then you have the really highly parallelizable stuff at the bottom, which is all of the graphics stuff. And so we looked at different structures for those. And so the first block diagram that we drew tracked that pretty well. So we said for the high level game code, we're going to have an out of order CPU then. That's going to be Prescott or Tejas style CPU. The next level is going to be these more simpler in order cores that we're going to do, and then we're going to have a GPU. So where we ended up was basically the bottom two layers, and we threw away the top one.
And why was that? Oh, because you were mentioning the multi-core.
Yeah, of course. Yeah, because it was like we would realize how much we're actually going to pay for one of these guys up here, and we can get so many reasonable ones down here. So that's the way we went.
It's the power of multi-core, huh?
Yep.
Excellent. So, and you're still working on the team, right?
Yep.
You run the team down in Silicon Valley.
Yeah.
And were you involved with the 360 Elite? I'm not a gamer, so I'm not. We just released that information on. It was on 10, I think, Friday night or Saturday night. What's that all about? The 360 Elite? Is it?
Well, we switched to black.
Oh, it doesn't target.
Is there anything else?
It doesn't target 40 core now. Oh no.
No.
We switched to black. Okay,
We
he's
tried-
definitely
we
not
tried-
in marketing, my friends.
We tried the white thing for a little while. It didn't quite work, so doesn't quite fit in with the decor with everybody. No, so I mean, bigger hard drive and the alternate video output as well. I mean, for my team's involvement, I mean, we had there's under the hood change. Well, any throughout the lifetime of the product, like I said, we'll be going through cost reductions, which has under the hood changes. So even something like the Elite, there's extra design work and verification that goes on to come out with that. But it's not. I don't personally say that I did this on the Elite, but if you actually look under the hood of the silicon and how that's changing over time, yes, there's things that we've done under the hood that my team has contributed to.
Excellent. So, I mean, the future is bright for Xbox.
You mean switching to white again?
Switching to green.
Green.
Xbox green. Well, I mean, I just think it's really interesting from a hardware architecture and software world, the way this
we have.
evolve.
I mean, we have a. I mean, with Xbox Live, I think we have a very compelling platform for the future. You know, the marketplace, video downloads. You know, still has a lot of potential. The Xbox Live Arcade. I mean, my kids play all the arcade games, so we're up there on Cloning Clyde and Small Arms and
cool
Marble Blast and stuff like that, which is great. I mean, there's a younger kids at home, you know, don't want to quite sit down, and some of the other first-person shooters, and you know, some of the even driving games are something a little bit more complicated for the younger ones to get. So, you know, the arcade ones it's just there. You power up the box, you know, scroll down the menu, pick one, play that for 5 minutes, and you know, it's a great casual gaming experience.
Excellent. So, just a few more questions. So, you know, without sounding too cheesy, you know, but I think it's a good question. I mean, what are you most proud of from an architectural point of view that you've done?
I think the whole package. I think we did a lot of work, and we optimized the box or the architecture for what we thought was relevant. I think the thing, if we had to say the one thing that does certainly stand out, and I think that is the early insight into the multi-core. I think that's
absolutely.
If anything, I think that would be my number one. But also, we came up with a architecture that is. I think we had the right balance between the multi-core and having something that is programmable. I mean, we certainly could have done more multi-core if we had wanted to, but I think we kept it to something where because we did go and talk to developers and say, well, how many hardware threads do you think you could program? And the guys were saying, well, you know, 6 to 8. I think we wouldn't have too hard. So it wasn't just that, you know, we picked 6 just because that's all we could afford. I mean, it is. We could have done more simpler ones and had less floating point on some of them or something like that. But you know, I think keeping it symmetric, so you have 3 identical cores, giving each one of them a reasonable amount of close coupling to the floating point.
Interesting.
Yeah, so I think that was very cool.
Absolutely. And from the software side, I mean, it's Win32, it's a subset of
And
it,
DirectX, yeah.
and DirectX, and there's lots of tools that these guys are familiar with using.
Yep.
And as you said, in the future, hopefully they'll be able to. I mean, you could still do an incredible amount of concurrency with 6 threads if you had a higher level abstraction that did the underlying locks and stuff. For
Yeah,
you.
these are hardware threads, right? So you can have as many software threads as you want as well.
So let's talk about that. What you know, I'm a software person, not a hardware person. Let's talk. What is a hardware thread? What's the difference between a hardware thread and a software thread? Just for the sake of conversation here.
So the hardware thread is basically how much state the hardware can keep track of it at any time. So it, I mean, the hyper-threading or something like that. It's basically the same thing. So even though within the processor itself you're not necessarily at the same clock cycle or doing 2 threads simultaneously. There are obviously up to the implementation, but it really means that at a very fine level, the hardware is able to pick what work I'm going to do, and if one thread ends up going off to memory and installing, the other thread can go in and pick up the cycle, pick up the spare cycles left behind. So it is almost like having 2 CPUs within one, because there are 2 threads of execution actually going on in parallel. Where a software thread is a high level OS based construct where and they may run for. They don't, so on the hardware themselves, they're not running concurrently at the same point in time. If you were to stop the clock on the CPU and then say, how many software threads do I have running now? Well, maybe there's some stuff down in the cache that's still left there from another thread, but for most intents and purposes, the pipeline is dedicated to that one software thread, and then the OS decides the scheduling for the software threads.
Cool. Very interesting. Well, hey, I mean, I appreciate your time coming up here to talk to us, and you were also, is there anything else that you want to get out there about what's going on under the hood in the Xbox 360?
Well, I mean, under the hood, I think the rest of the team, I haven't had a chance to really talk about them as much. I mean, I have 3 main functions within my group. I have the architecture team, I have the system verification team. Because we come up with these complicated architectures, we also need somebody that can say,
you're crazy.
We're crazy, or so we can verify that. And so I've spoken about the architecture verification guys. I mean, we did actually a lot of cool work there as well. So we did we bought an emulator from Mentor Graphics. That's basically a box that you can fit 60 million gates inside of it, and so you can take more or less the whole of the 360 and run that in simulation. So even before we had any chips, we were actually running real code on the design, and so we were able to iron out bugs well before we got anything back into the lab. And so when things got into the lab, powered up, and we were able to run the OS, not had any serious hardware bugs that would have prevented us booting the OS and running code and actually having a stable system. So those guys did a lot of great work. And then I have that work then gets taken on because we're sort of working at really low hardware level verification, but we also want to take some of those tests, package them up, and make them into high level tests as well. So I have a software team that does that and works on manufacturing diagnostics and things like that.
So let me ask you. I mean, you mentioned booting, BIOS, or are you using something else?
So yeah, I mean we have different stages of bootloader. But I mean, there's no point in time where you can hit F2 and go in and
boot into Linux and I just hacked onto the
yeah.
Just kidding.
Sorry.
But I mean, that is interesting. I mean, we think about people adding their own operating system. I mean, it's a hardware that supports a very specific type of operating system. It's what you've designed.
Yeah.
That's totally tailored towards extreme graphics, extreme performance, etc. And of course, you guys were smart enough early on in Xbox One to add networking support.
Yeah.
So it's a very compelling piece of hardware for gamers.
Yeah. Yeah. I think the online stuff is the future. I think it's cool.
Absolutely. And maybe we can distribute out some of the processing to 1 million nodes out in the internet world.
Yeah, I mean, for gaming, that's a little bit more challenging. I mean, for Solitaire, yes.
Excellent.
Halo 3, yeah.
Not going to happen, huh?
Yeah, because you have the tight, I mean, it's all, at some point you need to get within certainly 100 milliseconds from hitting something to seeing it on the screen. Otherwise, you.
It'd be kind of like
it's
clicking
not,
in Windows and nothing happening.
I didn't say that.
Double click on something and nothing happens. Oh no. Interesting.
So, yeah.
Well, cool. We'll follow this stuff because we're going to be following multi-core, many-core. It's an incredibly interesting problem. And congratulations to you and your team for designing a superiorly interesting hardware configuration called the Xbox 360, and also having the vision to see the many-core challenges of the future.
Thank you.
Thank you.